Dear students, class 11th, I take the specific heat. Whenever some substance is given the heat, then its temperature rises, and that depends upon the mass of the body also. So energy the heat energy per unit mass required to raise temperature by 1 degree Celsius is called specific heat. The heat energy per unit mass required to raise temperature by 1 degree Celsius is called the specific heat, denoted by C. So C equal to Q upon M delta T. Delta T, rise in temperature, or simply temperature change. Now you can see that this C specific heat is scalar quantity. You can see the unit. This is measured in calorie. If we take in M case, then this is kilocalorie, this is kilogram degree centigrade, kilocalorie per kilogram degree centigrade, or calorie per gram degree centigrade. Now you can have the dimensional formula. Now this C Q, this is the energy. So this is M1 L2 T minus 2 upon mass M1 temperature. This is now theta 1. So this M and M will cancel, and you will have C equal to M0 L2 T minus 2 and theta minus 1. So whenever there is change in temperature, then there is the specific heat. And when there is no change in temperature, then specific heat does not exist, or it becomes infinite. So due to at the time of phase transition, during phase transition, no specific heat is involved, because at that time temperature does not change, so C becomes infinite. Therefore, C equal to infinite. As the temperature goes down, as the temperature rises, then this formula is accurate. This formula is only for high temperature. This formula applies at higher temperatures. As the temperature reduces, then this formula is not applicable. At lower temperatures, at quite low temperature, the specific heat the molar specific heat follows the way TQ law is C proportional to T raised to power 3. T is the absolute temperature. T absolute temperature. So actually that at room temperature and somewhat low at the temperature where transition does not take place, then this specific heat plays an important role. The specific heat gives you that when the matter is given, that how much quickly or slowly it will absorb the heat. Higher the specific heat, higher is the absorption and emission of the heat energy, and lower the specific heat, then the body will take more time to heat up or just to cool down. Specific heat when expressed as per unit mass, then this is the specific heat for the substances at high temperature. When we take when we express it is per mole, then it is called the molar specific heat. So this should be quite, here I have written the molar specific heat, because this specific heat is taken in terms of moles. specific heat of water is highest and that of sand it is lowest. So these higher and lowest value plays an important role in our life because of higher specific heat of the water. The water has the abnormal behavior and sand is also have the abnormal behavior, and you can see that the water takes more time to heat up and also take more time to cool down. Similarly, sand have the lowest specific heat. It means that it heated up very quickly and cooled very quickly. So it plays a important role in our life. Specific heat of gases is expressed in moles. Then it is called molar specific heat. That I will tell you later in the chapter 12, we will study the thermodynamics. So specific heat of gases are different from those of the solids. So specific heat is contained by all kind of particle, all kind of phases, whether solid, liquid or gas. So you like this video? Share and subscribe. Thank you.